In this lesson, we're going to take a look at three more. We're actually going to look at angle, side, angle, 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 side, as well as a new one called HL. So the first two, just like our angle had to be included, this side must be included between the two angles for it to be angle, side, angle. This next one is kind of just going in order, angle, and then the next angle, and then the side right after that. So again, kind of, it's not an included side, but it is the side right after the two angles that are congruent. So we're going to mark our picture with what's given on this first one, that QS bisects PQR. And so we are given that information. We are also given that angle PSQ is congruent to angle RSQ. And so we're going to mark that information, PSQ and RSQ. And so the other angles that I marked here are the definition of an angle bisector, and that would be PQS and RQS. And so we have those marked in our picture. And then lastly, what proves that this segment in the middle here is congruent to itself? The reflexive property of congruence. And so now we have an angle, a side, and an angle. So angle, side, angle is our reasoning for those triangles to be congruent. Down here, if we have two triangles, so I'm going to kind of quickly just draw those triangles so that we can visually see them. And I know that L is congruent to Q, M is congruent to R, and then I also know that MN is congruent to SR. I could use that information to prove those triangles congruent, but I also have these angles congruent because they're the third pair, the third angles theorem. So in order for us to have angle, side, we need this angle here. Otherwise, you technically could use angle, angle, side, but we would need this third pair in order to get angle, side, angle. And so it's the third pair, and anytime you have two pairs of angles, the third pair must be congruent by the third angles theorem. The last one is what we call HL. There are some other ones that work for right triangles, but basically leg is the same as side angle side on a right triangle, and leg angle is the same as angle side angle on a right triangle. So all the rest of them besides HL are basically just a repeat of one of these four we've already talked about. HL is kind of the only one that is unique in the fact that if we were to label angle side, we would spell our bad word, which we talked about we don't do. But a right triangle, which is why we call it HL, if you have the hypotenuse and you have a leg on a right triangle, only right triangles, that's the only ones that this works for, then you do have congruent triangles. So angle, angle, angle doesn't work. Our bad word or our bad word backwards doesn't work, but all of these reasons do work. So keeping those in mind as we work through these examples. We're going to have all reasons possible. We're going to mark anything reflexive or vertical, or maybe alternate interior. Those also can be marked. And so here we're going to label. And if I go in order, I have angle, angle, side. Is that a reason? Yes. And I have that on the same side. We want to make sure that both triangles have it, not just one. Because if one triangle has angle, angle, side, the other triangle has angle, side, angle, that doesn't match up. And we have to have it match up on both. So this one, we do have some alternate interior because of the parallel lines. Excuse me. And then we have our reflexive. So we have a tick mark, which is a side. We have an angle, and then we have another side, and it does sandwich it. So SAS is the reason, and it does have it over here as well, sandwiched between. The next one, we want to mark our JL bisecting this angle here. And then we want to mark, well, K and M is already marked, and so we're going to mark our reflexive. And so we have an angle and an angle and a side. Remember, we start on kind of the outskirts. We don't jump around, and we go in order around. Angle, angle, side. Yes, that's a reason, and it does match up because we have that same thing over here. Angle, angle, side. All right, now we have this right triangle. Right triangles, again, are not always HL, but we do want to double check. If that's a right angle, then that's a right angle. We do have reflexive. So we have the hypotenuse, and we have a leg. So we do have HL since it's a right triangle. But again, right triangles could also still be angles and sides, one of our other ones we want to double check. But I always say start with HL and then try the others after that. Right triangles, but we only have a leg. We don't have the hypotenuse here, so this is a no. What do we need? We need the hypotenuse. So if it's a no, tell what else you need in order to actually have them be congruent. And then this one, we have an angle, a side, and an angle, and we have that same thing over here. So angle, side, angle. All three angles, remember we said all three angles is a no. Because the side lengths, it could just be like we have a 60 equiangular, but we could have an equiangular here, 60, 60, 60. They would have the same angles, but are those the same size? No. So we would need a side for angle, side angle for that to work. Let's mark reflexive. Again, a right angle. We want to double check hypotenuse leg first. Here's the hypotenuse. Here's a leg. So yes, it is HL. Again, it's not always HL, but it could be. And then again, reflexive here. It is a right triangle, so check HL. Here's an H, here's an L, and we have it on both, so HL. And here is our reasons kind of pictured so that you can use that if you need to make sure that you know all the 5 different ways to prove our triangles congruent.